Hi, there's a built-in data set in R, indomethacetacine, indometh, that has a data frame. So you can just start typing that, get the autocomplete and have a look at that. You can also explicitly load this into the environment with data, because it's a built-in data set, and now it will show up here once you've clicked on it with the usual view that we are used to. Now we can use that to do some plotting with the plot function. We can take our data set and take one column with the time, for example, comma, indometh, dollar, and then let's go for the concentration. And I'm going to close this and drag this a little bit bigger. And if I run this code, I will see this pretty ugly graph. But let's look at how to improve that. We will need the plotting documentation for that, and there are several packages that have a plot function. So opening the documentation with F1, remember, shows several options, all the packages that you have available or loaded. You can also explicitly do that with !plot. And then you can select the default scatterplot function in the graphics package. Right. So the general code is the plot function and an XY for coordinates, for scatterplots at least. So this is the example we just had, and now let's improve that a little bit. We're going to make the dots orange, and we're going to use a PCH thing. It stands for point character, i.e. what kind of points do we want, and 16 means full dots, so they're not just circles but actually filled dots. And we're going to add a little title too with the main argument. So this is the plot function that comes with base R. There's an entire dialect in ggplot, and that's perfectly valid and fine, but you do need an extra package or set of packages for that, and so you can also just use the base R plotting, which we'll be doing here. If you get the error figure margins are too large, just drag the plots panel in RStudio bigger. Alright, so here's a little exercise that you can do, and then pause the video and then we'll get to the solution now. Right, again we're having a scatter plot, so we're plotting two things, and then we use xlab and ylab for the labels, and here we use type L for a line plot. So here is a little demo to create nice looking graphs. So we're starting out with something similar to the solution from the last exercise, and now we're going to add a couple of things. We actually want the numbers to be upright. A label axis style 1 will turn these numbers upright, so let's have a look at that. Oh, it looks pretty good. We may want a different point character, maybe 3, for little crosses. That might look nice. And we might want a color, and we might want to give a hexadecimal color, which we do with the hashtag, and then, and then maybe lots of red, so go full red, and then 0 green and 0 blue, so we would get red. This would look fairly nice, and now we can add some transparency too in the next one, so maybe like half-ish or a third-ish transparent, so 66, and then the points are semi-transparent. Everything behind each other will have more color intensity. Our title is a bit big, so we have things like CEX for bigger dots, character expansion size, which will give us bigger dots once it has loaded. And then we have something like cex.main for the title, which we can set to maybe something like 0.7 to get a smaller header here. Now we can also do is set the parameters of the device, and what we're going to do is set the margins MIR, which will take a vector of C. We haven't actually done this in this course, we've kind of jumped over that, but C will create a vector, combine a couple of numbers, and so we're going to set 3 at the bottom and the left, that's the order, top and right. So, and if we set that and run plot command, then the margins will change and look a lot nicer. Now we have lost our labels on the axis. They're kind of barely visible here, and so we can get this back in with MGP for margin placement. That takes 3 values, the first being the distance of those labels from the plot, the second being the distance of the numbers from the plot, and then we're going to use a 0 for the line distance to the plot. And if we set those parameters and run the plot command, normally this happens instantly. My computer is a bit overloaded right now, and then we can see how these get into the screen. And now we have a graph that already looks a lot nicer. We can do something similar with that second graph. If we run this command, we get an error. That means we should briefly look at the things that we select. I have a keyboard shortcut for the structure of that, and the structure here looks good. And for this, we actually have a character string because I have not actually run that piece from the solution yet. So if I do this further up in the script, you will notice that the mass datum will change from character to an actual date. And there we go. And if I drag this bigger again, then my figure margins error disappears too. Right, so now I can run this and I get a line graph. To improve that one bit by bit, we do not really need a label on the x-axis. That's kind of clear, so we're just going to put nothing in. That looks pretty good. And these axis labels are actually not really helpful by default. So x-axis type equals none. We'll suppress that completely. And maybe we want a thicker line to a line width, it's going to be like 3 or something. And then again, we can do things like putting the numbers upright to make it look nicer. Now, what we're going to do is we're going to use a package that I wrote that has a bunch of my functions, that has a sadly egocentric name, Berry functions. You would need to install this first if you don't already have that installed with Berry functions. I'm just going to cancel it now because I already have that. And this has a function month axis, and this will add a very nice month axis to the current plot. And the display is driven by R still. It's nothing to do with my function there. And I thought that's just a nice little thing to show. And here I have an overview of plot arguments that I use a lot. Again, if you're using ggplot, this is an entirely different dialect and it has a different syntax too. But you can get pretty far with base R plots. Now, we will still need to export plots, and we're not going to do the point and click interface in RStudio because as soon as you drag your windows to a different size, your reproducibility is broken, and you don't need to because it's all available within R. We're going to put a couple of plots into a PDF device or a PDF file, and that can be opened as a device with the PDF function. It needs a name and some parameters if you want to set those. And you can run a couple of plots and then close the device. I'm going to show you this as a coding demo. Now, normally if you run a plot somewhere, plot command, you will see this in the device in RStudio. But once you've opened the PDF and run some plots commands, they do not get displayed here. Like we could add this one too if you want. And then with device off, we're actually closing this, and now it tells us which is the currently active device, which is the RStudio device. So if we now plot something again, we would see that here. Now, I have a little handy function called open PDF or open file. Both will usually work. Open PDF will try to do that with Sumatra viewer if you have that on Windows, and then we can put in our file name. Now this is not really a good file name, but it will do for now, and then it will open that in the browser, in the PDF viewer, where we will have these different graphics now included. So that's the way to export graphics. This is available for PNG and whatnot as well. And if you make sure that you open your file in a viewer, not an editor, so Sumatra is a good one, you can see live edits too, to just tweak it to exactly the right format and size and spacing and whatnot. Alright, that's it for plotting. In the next video, we'll be looking at for loops. See you then.